Hey guys, welcome back. I'm going to try to take it easy on you today. I know the last couple of days have not been easy. Hopefully at least last night was easier than the night before. And that's the thing with this class is as long as you ask your questions as you go and then you go back and rework those problems, you'll get the hang of it. It takes a little while at first because it's pretty hardcore, but it all comes together. Just keep on asking your questions. All right, so first, a problem that I'm kind of hoping you can do without me. So if I ask you to do the derivative of this, and I'm going to give you like a review assignment today where you have a lot like this. First, how do you think you would approach this problem? I hope that you thought to yourself, this piece is a product rule, and this is just a separate term that I already know the derivative of. This guy, the derivative of that is just -5. So I'll have a -5 at the end of my answer. This piece will require a product rule. Okay? So I would like you to hit pause and try this problem on your own. So the first term is a product rule. I separate my two factors and find their two derivatives. The derivative of x squared is 2x. The derivative of sine x is cosine x. And I do my crisscross. So the derivative of the first term here in red would be x squared cosine x plus 2x sine x. Very straightforward. And then the derivative of -5x is just a -5. That altogether, believe it or not, that's it. It was easier than it looked. So that was a quick review of a real straightforward problem of the product rule without you having to simplify a bunch of things. Okay, so I've been holding back teaching you the rest of the derivatives because I know how overwhelming it can be, but dun dun dun. Okay, so this is all of them. Well, at least it's all the trig for now. You know the three that are on the left. We've already learned those. And those are the three that really you have to know by heart. You need to know those cold. Okay? The three on the right, you're still supposed to know these. But I'll be honest with you, they are not used as often. But just know that if you need to find them, you know where to find them. You should memorize them. But they really aren't as common as the others. So do the best you can to memorize them. Maybe secant shows up the next most common. I almost never see cotangent or cosecant. All right, so I'll go through them with you, but I think you need to just know that you can look them up, you can find them. There's a page in the front of your book that has all the derivatives, so when you run across one that you have forgotten, probably one of these three, just know that you can look it up and find it real quick. Okay, so derivative of secant is the only one that really sticks in my head. I really can't remember these two at all. Derivative of secant is secant x tangent x. We can prove it the same way we did the derivative of tangent. We can use a quotient rule. But just memorize it for now. Derivative of secant is secant tan. And I don't know why I say this, but seek and seek a sexy tan. I'm sorry. I'm embarrassed to say it out loud. Seek a sexy tan. It really doesn't even help. Maybe it does. I don't know. But for some reason, I can remember that one. The other two, cotangent and cosecant, all I can say regarding that one is the two that start with C's have negatives. Good luck memorizing them. If you have to, I'll tell you if you have to when we get closer to the AP exam. In past years, you had to memorize them because you couldn't take your test at home with your notes in front of you. Last year, you really didn't have to memorize them. So memorize them if you can. Give it a best shot if you're good at memorizing things. But you will have some homework today that I know at least has this one in it. Okay? All right. So today, that's not even your homework. Today, I'm going to give you a review assignment where it looks a lot like this problem. Okay? It's just a worksheet. And it's just because I want you to take the time to redo any problems in your homework that you needed help with. If you didn't get it the first time all by yourself, then redo those problems. Okay? Hopefully the worksheet goes well. There are some problems in the worksheet, though, that I want to at least walk you through. So I'm going to pull up the worksheet right now, and I'm going to ask you, how would you approach this problem, that problem, and this problem? So as long as you know how to go about it, I think you'll be all right. Some of them are still going to be tricky, well, because that's calculus. So hold on just a minute, pause. So this is a copy of your homework, your worksheet. So let's go through most of these and just make sure you know how to get started, okay? So number 1, this one, you have no choice. It's not a single term denominator. There's nothing you can really do. You're going to have to do a quotient rule, okay? Number 2, you could do a product rule as is, but me personally, I would rather FOIL and then do a power rule. Remember, when you FOIL and when you do the derivative, both, this square root of x is just an x to the 1/2 power. And when you work that out and you remember that x cubed times x squared, for example, is x to the 5th, you remember that when you multiply, you add exponents. I think that one's going to be easier to do with a power rule if you FOIL first. Number 3, no choice, got to do a quotient rule. Number 4, just be careful. The 3 is a separate term, and the derivative of a 3 is a 0. That sucker is gone. And all you're really doing is the derivative of this guy. Be careful, though, the negative is still there. So when you split it up, you'll have one factor that's a negative x to the 4th. You'll have another factor that's a cosine of x. Do your two derivatives and your product rule. Okay? Number 5. The 2 has to go with either the x squared or the e to the x, not both, because it's not a plus sign in between. You're not distributing it. So I would break it up. I would do the 2x squared as one factor, the e to the x as another, do the two derivatives, and a product rule. Okay, number 6. Okay, number 6, this is a power rule. Okay, move that up. That's really written as 10x to the negative 1. And once you rewrite it like that, now you can do the derivative with a simple power rule. Okay? And then make sure your answer has only positive exponents. The derivative of secant is one of the new rules that I taught you. Secant tan. Number 7. So number 11 would be a product rule for this guy. And then the derivative of negative 9x is just a negative 9 at the end. Number 12, hopefully you know how to approach that. You could do a quotient rule, but it would certainly be much easier to treat it like an STD and split up. Number 13, product rule. These guys go together, and then the e to the x. 14, no choice. You get stuck on that one. You're going to have to do a quotient rule. Let's skip to 16. So 16, equation of a tangent, you need two things. You need point and slope. To get the point, you plug the 1 into the original equation. To get the slope, you plug the 1 into the derivative, and the derivative of this will require a quotient rule. So I haven't given you a hint on all of them, but I think I've at least given you a hint on most of them. I'm going to go ahead and say, just because of time and I don't want to make you crazy again another day, feel free to skip number 8 and number 10, and hopefully the rest are manageable without pulling your hair out. If you feel like you've got it in you, go ahead and do 8 and 10. All right, good luck, guys. Hope you're doing okay.